Good morning and welcome. Today we are going to be learning about approximation, and this video will be the first in the series, as it's going to only be an introductory aspect of approximation. The next video in this series is going to be about the errors in approximation. So in this class, we are going to learn the meaning of rounding off of numbers. We are going to learn the difference between estimation and approximation. We are going to learn to round off to a given place value and decimal place. We are going to learn to round off to significant figures. And we are going to solve problems related to approximation. What is rounding off of numbers? Rounding off of numbers simply means rounding up the numbers 5 to 9 to 10. That means when you are to round off those numbers, wherever you see the number 5, 6, 7, 8, or 9, you replace it with a 0 and add 1 to the number immediately after it. Whereas for the numbers 1 to 4, you round them down to 0, meaning that you replace them with a 0, but you don't do anything to the numbers after them. So either way, when you round off a number, that particular digit is replaced with 0. However, if the number is high enough, you add 1 to the digits after it, but if the number isn't high enough, you don't do anything to the digits after it. What is approximation? Approximation, according to the dictionary, is an imprecise solution or result that is adequate for a defined purpose. And what is estimation? Estimation is the process of finding a rough calculation or assessment of the value, size, or cost of something. Now, these two terms may mean the same thing in different in different topics. However, in mathematics, there is a definite difference between approximation and estimation. And in terms of calculation, the difference between approximation and estimation is when we round off our numbers. In approximation, you round off your numbers after you have calculated, while for estimation, you round off your numbers before calculation. Here is an example to show you the difference between both of them. Here we are to find the approximate value of 256 multiplied by 314. To get the approximate value, we first multiply and get the actual value. Then we approximate to the nearest tens of thousands. Multiplying to get the actual value will give us 80,384. Then the approximate value is going to be 80,000, since we will round down 4, round up 8 to give us 4 here, and then round down this 3 to give us 0. So this becomes 80,000. However, if we are estimating, we first round off before we calculate. So we round this up to give us 0 here and 6 here. Round this up to give us 0 here and 3 here. So this gives us 300 over here. Whereas we round down 4, round down 1, and we have 300 here. So the estimate of 256 times 314 is going to be 300 times 300, which is 90,000. So we can see that there is a definite and a clear difference between approximation and estimation in mathematics. You should not confuse both of them. If you're asked to find the estimate of a value, don't find the approximate value. And if you're asked to find the approximate value, don't find the estimate. Also, one thing that you should also learn from this, one more thing that you should learn from this, is that approximating before you complete your result changes the value of your result, and that is something you must always avoid. I'm going to touch more on this in the next video, where I talk about approximation errors, including relative errors, percentage errors, and absolute errors. However, that will be discussed further in the next video. Here we are going to deal with approximation, and there are 3 basic ways in which we approximate. We can approximate to a decimal place, we can approximate to a whole number, and we can approximate to significant figures. Approximation to a decimal place means rounding off all digits until you are left with a specified number of digits after the decimal point. So if you are told to approximate to one decimal place, it means you should have only one digit after the decimal point, and so on. So this is an example. We are told to approximate the number 13579 to one decimal place, two decimal places, and three decimal places. When we approximate this to one decimal place, all these numbers, all these digits, 9753, will be rounded off. So 9 will be rounded up. This becomes 8. 8 will be rounded up. This becomes 6. 6 will be rounded up. This becomes 4. 4 will be rounded down. So we are going to have 0.1. In this case, 9 will be rounded up. We will have 8 here. 8 will be rounded up. We will have 6 here. 6 will be rounded up, and we have 4 here. So our answer is going to be 0.14. And the same thing happens here. So we have 3 digits after the decimal place here, 2 digits after the decimal place here, and 1 digit after the decimal place here. And that is 1 decimal place, 2 decimal places, and 3 decimal places. Rounding off to a whole number simply means you should round off every digit after a specified place value. And if we are told to round off to whole number, that means round off to the nearest units. So here we are given the number 135.79, and we are told to round off to the nearest whole number and to the nearest tens. Rounding off to the nearest whole number simply means we don't want to see any decimal points in this number. So you round off every number after the decimal points, and in that case we are going to have 136, rounding off 9 and 7. And if we are told to round off to the nearest 10, that means we don't want to see any digit after the tens. That means no unit and no decimal places. So we are going to round off 5, 7, and 9, and that's going to give us 140. Approximating or rounding off to significant figures means round off until a specified number of significant figures is left. Now this might be a bit tricky because significant figures can be before or after the decimal places, unlike rounding off to decimal places and rounding off to place value. So what are significant figures? First of all, we should note that every non-zero digit is significant. So wherever you see 1, 2, 3, 4, 5, 6, 7, 8, or 9, they are all significant. And that means only 0 can be insignificant in a number. Now, insignificant and non-important don't mean the same thing in this context. Next, we need to note that every 0 between two non-zero digits are significant. So when you have a number such as 102, the 0 in between is significant. 5.403, that 0 is also significant and should be considered when counting. Every 0 after a non-zero but before the decimal point is significant. So when you have a number such as 50 or 100, the zeros that make up those numbers are significant and should be counted. Now we come to the ones that are not significant. Every 0 before a non-zero is not significant. So when you have a number such as 01, the 0 in front of 1 is not significant because that number is 1 and it will remain 1 without that 0. However, that is not only the case. When we have 0.02, we know very well that those two zeros in this decimal number are important, but they are not significant. So when we want to start counting our significant numbers, we start counting from 2. However, that doesn't mean that the zeros are not important. If you remove them, this number loses its value. It changes from being 200ths to being the unit 2. So this is an example. Approximate the number 10 0.05095, and 54,753 to 3 significant figures. 10 to 3 significant figures is going to be 10.0. 0.05095 to 3 significant figures is going to be 0.0510, because our significant figures will be 5, 0, and 9. These are the first 3 significant figures. We are going to be rounding off 5. However, when we round off 5, it becomes 10. So we replace this with 0 and add 1 to 9. Adding 1 to 9 makes it 10. That means we are going to have 1 at this point and 0 at this point. So we did not round off 9, but that doesn't mean that we are not going to change the value of 9 when we add 1 to it. And for the number 54,753, we are going to, the first 3 significant figures are 5, 4, and 7. We are going to round off everything after it. That means rounding down 3 and rounding up 5 to give us 54,800. I hope you're able to learn something new today. Here are some practice assignments. Approximate the following: 1,534 to the nearest 100, 74.0528 to 3 significant figures, and 74.0528 to 3 decimal places. Thank you. See you later. Don't forget to ask any questions you have in the comment section below.